Okay, this video is going to be going over finding the domain of expressions. So some things we want to know before starting on the left here are our restrictions. So we can never divide by 0, and we can never take the square root or any even-powered root of a negative number. So that means if we have a root like this and the n there is an even number, we cannot have a negative number for x. So like a square root, the n is 2, and we cannot have a negative number under there. And then we also want to review what factored form looks like. So when we multiply this out, it's like AC plus AD plus BC plus BD. And this AC here, which is in purple, is always giving us like our x squared term when we organize it correctly. And then the AD and the BC, which are like the two outer ones and then the two inner ones, are giving us our x terms. And the BD is giving us our constant term. So we can see that here. I did a little example. So the 3x and x are giving us our x squared term. The 5x, the inner, and then the 3x and -1, the outer, are giving us our plus 5x minus 3x, which becomes plus 2x. And then our 5 and our -1 are giving us the constant term of minus 5. Okay, so we can look at this first problem here, and we notice there's no roots, so we're not going to have to worry about the second restriction. But we do have a fraction, and so we're always going to have to check that what's in our denominator um, will never equal 0. So that means this cannot equal 0, this portion. So how can we solve for that when we have like 6x squared minus 11x plus 4 equal to 0? We want to find what x values cause it to equal 0, because then we have to say x cannot equal that. So this one's a little trickier since we don't just have x squared alone, we have 6 multiplied by x squared. But we can do it. We're just gonna think of our factors. So for 4, we would have 1 and 4 and 2 and 2. And for 6, what we could do would be 6 and 1 and 3 and 2. So then I'm just gonna draw here what I would have. And then we can kind of just guess and check pretty quickly. There are ways you can think of this more methodically, and you might kind of get used to that as you practice more and more. But for now, you could really just try them. There's not too many possibilities. So let's say I did 6x and x, and then I could try 2 and 2, right? And I know in between here, I'm gonna have to have um, negative signs for both of them because my middle term is negative, which means that I have to have a negative somewhere, right? So that I'm subtracting to get a negative term. If I only had plus signs, I would never get a negative number. But my constant term is positive, which means I have to multiply a negative by a negative to get it, right? Because the only way we can get a positive constant term is if we multiply two positive numbers or two negative numbers. Since I know I have to have at least one negative number for me to get a negative 11x, it's going to have to be two negatives. So we look at this. So really what we care about here is seeing what our middle term is going to be, right? Because we know that 6 and 1, 3 and 2 will work for 6, and that 1 and 4 and 2 and 2 will work for getting us a constant term of 4. So we want to see, do they give us this middle term? So we will test that out. So let's see here. If we did this, we would have negative 12x minus 2x. That does not equal negative 11x, so we know that's wrong. Okay, let's try, we can try 1 and 4, like that. That would be 6x, or sorry. it would be negative 24x minus x. That does not equal negative 11x. Okay, we could try switching them, right? Like put the 4 here and the 1 here. Then we would get negative 6x minus 4x. Close, but that's not negative 11x. So we're going to have to change what we're doing with this term. So let's try 3 and 2. Okay, so we can try 1, 4. Let's see what happens. This gives us, so this will give us negative 2x, and this will give us minus 12x. That's not equal to negative 11x. So let's try switching them. 4 and 1. This is going to be negative 8x, and this is going to be minus 3x, and that finally equals negative 11x. Right, so then we know that this is the correct factorization. Okay, and you can also just multiply it out again if you want to make sure that it all works. All right, so now we know, okay, so we cannot have this equal 0, so we're going to see what x values would give us 0. So I can solve, so 3x minus 4, if this equaled 0, that'd be 3x equals 4, x equals 4/3. Okay, and then if this factor equaled 0, that'd be 2x minus 1 equals 0. So 2x equals 1. So when x equals 1/2. Okay, so I know that x cannot equal 4/3 and x cannot equal 1/2, right? So then to write this in my set builder notation, I'm going to say d equals x, element of all real numbers, such that x cannot equal 1/2 or 4/3. Right, and then that is the final answer. Right, so moving on to problem B. So I don't have a fraction here, so I'm not going to have to worry about, or sorry, I don't have a root here, so I'm not going to have to worry about that restriction. But I do have a fraction, so I have to make sure that the denominator cannot equal 0. Right, so what I can do then is say x squared plus 1 equals 0 and see what x values are going to give me that. So I can move over the 1 and get x squared equals negative 1. And then what you have to notice here is that a number squared will never equal a negative number, right? Any number that we square is always a positive number. Like even if I do negative 2 squared, gets me a 4, right? So this is impossible. This will never happen. So our answer is pretty simple. We can just say that our domain is all real numbers, right? So if you want to write this in the set builder notation, it would be like x is an element of all real numbers and nothing else because we don't have any restriction to put, right? Okay, so that would just be our answer. Okay, moving on to C. So this one, we have to worry about both restrictions, right? So first we have the root. So we know that this can't be negative. Okay, and then we also know that this can't equal 0, right? The denominator. So let's think about the root first. So if we have square root of x plus 10, we know that x plus 10 um, can not be negative, so we can say that it has to be greater than or equal to 0, right? So then we're going to subtract 10 from both sides. And now we know x is greater than or equal to negative 10. Okay, and this makes sense because if we think about it, like if we had, say we had negative 11, right? Negative 11 plus 10 would be negative 1. So we would have a negative 1 under the root. So this restriction makes sense that we have to have x greater than or equal to negative 10. Okay, and then here This one's, you don't have to do like any factoring. We just know x is our denominator and it can't equal 0. Well, there's our answer, right? Like that's all that's there and it can't equal 0, so that's just x cannot equal 0. All right, so these are our two restrictions. So to write it in the set filter notation, we say x is an element of all real numbers such that we have x is greater than or equal to -10 and x cannot equal 0. Okay. All right. Now we will go to V. And I have a little hint here. So we don't see a root, so we don't have to worry about that restriction, but we do have a fraction. So we know this cannot equal 0. So to factor this, you're going to want to remember the difference of squares, right? So you want to recognize that 81x squared is a square, right? Because like 81 we know is 9 squared, and x squared is just x squared. So that's 2 squares, so we know that this is a square. And then 49 we know is 7 times 7, so that's a square. So we have, if we're like following this formula, so we have a squared minus b squared, right? And we know our a equals 9x, right? Because if we had 9x times 9x, we would get our 81x squared. And we know our b equals 49, right? Sorry, b equals 7, because 7 times 7 equals 49. Okay, so then what we can do, we have our a, we have our b. We can write this as 9x minus 7 multiplied by 9x plus 7. Okay, and then we just have to solve. So we have 9x minus 7 equals 0. 9x plus 7 equals 0. Okay, so this is going to be 9x equals 7. So x equals 7 ninths. Okay, and then this is 9x equals -7. So x equals -7 ninths. Okay, so those are the two things we can't have. All right, so then if we want to write this out, we would just say our domain is x is an element, x is an element of all real numbers such that x cannot equal plus or minus 7 ninths, right? So that just means it can equal positive 7 ninths or negative 7 ninths. All right. Okay, now we will look at this one. So we have square root of x minus 15. Then we know this restriction is going to be that we can't have a negative number here. Can't be negative. Okay, so I'm going to say x minus 15 must be greater than or equal to 0. So I can add 15 to both sides and get x is greater than or equal to 15. Okay, and then again, we can kind of just check, say I had like 13. If I had x equals 13, it would be 13 minus 15 equals -2. So yeah, I can see that this is the correct restriction. And then, yeah, if I picked a number greater than 15, like if I had x equals 16, 16 minus 15 equals 1, and that's positive, so we're good. So we know our answer is correct, and we can write it out. X is an element of all real numbers such that x is greater than or equal to 15. Okay, and that is our answer. And then here, so this one, we have to look at both restrictions. So we cannot have a negative number under a square root. And then we also can't divide by 0, right? So let's look at the root first. So we have square root of x minus 4. So we know that that means x minus 4 must be greater than or equal to 0. Okay, I add 4 to both sides, which gets me x is greater than or equal to 4. And you can check this similarly to how you do in E. So then we just need our denominator. So we have x plus 2 cannot equal 0. Okay. And if I kind of like subtract 2 from both of these, I'm going to get x cannot equal negative 2. Right? Because negative 2 plus 2 equals 0. So I have my two restrictions, and I can write x is an element of all real numbers such that so let's look here. So our two restrictions are x is greater than or equal to 4, right? And x cannot equal negative 2. So I could, it wouldn't be wrong if I said that these are both the restrictions. But what you'll want to notice is that negative 2 is not greater than or equal to 4. So that's kind of already covered in this restriction, right? If we have that, um, like if we look at the number line and we have 4 here, we already know x can only be here, right? Because it has to be greater than or equal to 4. Negative 2 is over here. So if we have that x already has to be greater than or equal to 4, we really don't have to say that it can't equal negative 2 because we already know that, right? So our answer can just be that x is greater than or equal to 4 here. Okay?